Hello everyone, in our series of experiments on computer graphics, today we will be discussing the topic of perspective projection or 3D projection. So the idea is to start with a 2D figure, like let's assume a triangle, and try to do a projection of it in a 3D environment. So our final aim is to get a 3D drawing from a 2D structure. We will be taking the coordinates of that 2D polygon and we will be just projecting it on our display in a manner such that the resultant diagram should look 3D. So what will be the inputs we'll be taking? The basic inputs we'll be taking is the coordinates of the polygon and the depth or the width which we want to show in our 3D diagram. Okay, we've just moved to the coding part. If you just have a look here, I have defined a function here, draw 3D. What it does is it draws the complete diagram in parts. The first thing this draw 3D is does, it first of all takes the coordinates of the shape which we want to start with. For example, it's a triangle. After taking the coordinates, it takes the depth which we want to create, and after that, in this for loop you can see we are taking the three coordinates. If it's a triangle, we will be taking three coordinates. Fs here represents the number of sides it will have, and it draws it the front face, which is this one. If you see in this diagram, there are two faces of this 3D diagram. This is our final aim which we want to get using the triangle. So the front face is drawn simply using this for loop. This is a bit complicated because I've used this kind of for loop multiple times for the two sides. Like for drawing this side, I've used this for loop here, and I've used this same for loop again here to draw the side which is behind this one, which is a bit to the upper side in this window. So just to make you understand easily, I will go step by step. The very first step is to get the coordinates using the for loop. We are using the for loop accordingly that if we want to start with a square, we will be taking 4 coordinates, otherwise we will be taking 3. If we use a triangle or whatever shape we are using, we have to take accordingly. Now we will be just using line function as our basis to draw the diagram. This is the loop which we are using. So we take the x and y coordinates. We will, for triangle we will be having 3 different coordinates. We will take them pairwise. For example, in this diagram, for achieving this output, I took these coordinates 150, 150, 400, 50, 275, 275, and the depth was 10. So I took the 3 pairwise, and we will be using this line functions to draw the 3 different lines. This is the loop. This if function will be used only if it is the turn to draw for the third edge. The basic idea is to take each of the coordinates pairwise and draw the 3 lines to get the very front face. This is what this algorithm, this third step, is trying to do, and this if and else loop is what is actually used in this for loop here. So we are using those if and else statements to draw the front face. And how do we actually differentiate it between the front face and the rear face? You can see here, after xi I'm adding some terms. These are some constants I'm adding here. Even in this is for the top view, this for loop, and here I'm adding 200 as constants. So if you look at this algorithm part, I'm adding some constants just to give the separation between the front face and the rear face so that both of the faces can be visible in one diagram. And this, in the side you see there is some width. This width is defined by the depth which we take as an input. So that depth, actually how it works, that depth is itself used to draw the side view. So what this depth is actually defined is actually used to fill in the separation between the front and back face. So this depth is added in the line function in the x and y coordinates accordingly, just as to join the two faces together. Like in this diagram, the triangle at the back and triangle at the front are joined by some lines. So these lines are these are, I think, if you count, three lines are there which join them. So these are drawn using that line function and that depth value which we give as an input. So that's what the idea is, to draw. But what can be the variations here? So if you look at the kind of inputs I've taken, for the first one I've taken three coordinates for the triangular shape and given the depth as 10. So this is the shape we get. If we increase the depth, like the depth makes is made 50, then we get a much wider prism like shape, which is more like a pyramid, I would say. If you increase the number of sides to 4, we will end up getting a cuboidal shape. It's much more like a box. And if we increase the depth here, it's a perfect cuboid which we can see here. So I think that's pretty much all. Thank you everyone for watching the video.